Hello everyone, welcome back to Codecox. I am Shamil Duranga and today I am excited to share with you an important topic in data structure and algorithm, the heap priority queue. The structure might sound a bit technical at first, but don't worry, I will break it down step by step. By the end of the video, you will know exactly what the priority queue is, why we use heap to implement it, how max heaps and min heaps differ, and even see some real life application and code examples. What is the priority queue? Let's start with the basics. A priority queue is a data structure where elements are served based on priority, not on the order in which they arrive. Normally, a queue is before first in, first out, like standing in line at a shop. But imagine you are in a hospital emergency room, someone arriving with a critical condition should be treated first, even if others were there before. That's exactly what a priority queue does. It allows us to assign a priority value to each element and always retrieve the one with the highest importance, or in some cases the smallest value depending on the use cases. Next, why use heap for priority queues? Now that we know what a priority queue is, the next question is, how do we implement it efficiently? We could keep a sorted list, but insertion would be slow or of n time in many cases. Instead, we use a heap. A heap is a special tree-based structure that gives us very efficient access to the highest or lowest priority element. It's a complete binary tree. It's sorted as an array in memory, which makes it simple and fast to manage. It always maintains the heap property, ensuring quick operation. Because of this, insertion or deleting an element takes only logarithmic time O of log n, while peaking at the root is constant time O of 1. Next, max heap and min heap. There are two common types of heaps used in priority queues. Max heap. The root is always the maximum element. That means when you pop from the heap, you get the largest value. This is used for max priority tasks. Min heap. The root is always the minimum element. Popping gives you the smallest value, used for min priority scenarios. In practical terms, if you want to process the biggest job first, use a max heap. If you want to process the smallest distance or smallest cost first, use a min heap. Next, applications. So where do we actually use heap-based priority queues? Task scheduling. Operating system often use them to run tasks in order of priority. Dijkstra's algorithm. When finding shortest path in a network, you repeatedly choose the smallest distance, perfect for a min heap. Data compression. In human coding, heaps helps pick the two smallest frequency node efficiently. Simulation system. Games and simulation use them to manage future events, always running the most imminent on first. These are not just academic examples, there are real practical uses that affect system we use every day. Next, basic operations. Let's talk about the key operation of heap priority queue. Insert. Add a new element. The heap rearranges itself to maintain order. Peak. View the root, which is always the highest or lowest priority item without removing it. Delete. Remove the root element and the heap to restore the heap property. These three simple operations from the backbone of the entire priority queue functionality. Next, code example. Insert and delete. Let's see how we implement this in code. Here is a Python example using the built-in heap queue module. What's happening here? We push 4, 2 and 7 into the heap even though we push 4 first. The smallest value 2 rises to the root because it has higher priority in a min heap. Heap pop removes the return the smallest item 2 in the case and recognize the heap, so the next smallest is at the root. PQ 0 lets us pick at the smallest remaining element without removing it. Next, uh, task scheduler simulation. Each task has a priority, and heap process tasks with the highest or lowest priority first. Next, summary. Let's quickly recap what we have learned today. First, a priority queue manages element by importance, not arrival today. Using a heap makes it efficient to insert, delete and pick. Max heap gives you the largest element first and min heap gives you the smallest. Applications include task scheduling, distract algorithm, data compression and simulation. We saw how to insert, pick and delete elements in a priority queue using Python code. Thank you so much for watching video. I hope you learned something new about heap priority queues today. If you enjoyed this, please like, subscribe to CodeComs. I'm Shamadan. I will see you in the next one. Thank you.